This is Stephen, and in this video we will discuss how to quantify how stiff a tricuspid valve is, or tricuspid stenosis, with echocardiography. And you may notice some similarities with our mitral valve, mitral stenosis video. So let's start off with looking at either the RV inflow view. So that would be something like this. You've got your right atrium, your tricuspid valve, and then that empties into your right ventricle, and this is parasternal long, but we've just tipped our probe. Or you can also assess it in the apical four-chamber view. Left atrium, left ventricle, and right atrium. And what you can do is you can measure your continuous Doppler with either of those views. And if you have a stiff tricuspid valve, you may see something like this. You may see blood going in, and you may see some tricuspid regurg, and then you may see something like that. So this up here that I'm shading, that's blood flowing through the stiff tricuspid valve, and then this nice rounded jet down below, that would be your tricuspid regurg. And you can take the and the reason I've shaded this in red here, this is a continuous Doppler, not a pulse wave. Now you can take the mean gradient. Remember, peak gradient is 4 times the Vmax squared, but mean gradient, your computer will calculate for you, looking at all the tiny little velocities. You can get your mean pressure gradient. And if that is greater than or equal to 5 millimeters of mercury, that is a severely stenotic tricuspid valve. You can also, if you recall that concept I mentioned before, where you look at the slope of this line, and you basically, this whole thing is your deceleration time. You can take 0.29 times your deceleration time equals your pressure half time, the time it takes from your pressure to go to from whatever this pressure would be to the pressure, it'll be, somewhere, let's say it's like right there. The pressure is half of the original value. And then if you take 190, this is again an empirically derived formula, 190 divided by your pressure half time, that approximately equals your tricuspid valve area. And the numbers to remember would be that a tricuspid valve area of 1 centimeter squared, or by extension, a pressure half time of 190, either of those would be severely stenotic. So we use our continuous wave Doppler, and we can either look at the mean gradient. If that is more than 5, we're likely dealing with severely stenotic, or we can look at the slope of our curve. And just like with the mitral valve, the flatter this line here, the flatter this is, the stiffer your valve. Pressure half time of 190 or tricuspid valve area of less than or equal to 1 would correspond to severe stenosis.